All right. So today's general plan is to take up our heuristics from last time and talk about three more. I guess 3 more types of mistakes we make because of our heuristics. But before that, a couple business things. One, midterms due tonight at midnight. If you haven't turned it in yet, get it in by midnight. As I said last class, I'm not going to be a super stickler about it. So just get it in when you can. If it's not till tomorrow, that's fine. And if you need an extension for any reason, like you're going to get an extension, even if it's like one tonight. And you're like, professor, something came up. I couldn't get to it. Can I have a few extra days? The answer is going to be yes. So don't stress about it. Even if like I'm in bed and I haven't responded by the time you go to bed, like the answer, unless unbeknownst to me, you killed my mom or something, you can have the extension. All right, so that's all we're going to be. That's the business stuff. And my hope again is to get them back by next Tuesday, but that's seeming less likely because there's a couple more people who've had emergencies. And so it's probably going to be a week from today, unless somebody's emergency keeps going, in which case it'll have to be a couple classes after, because I don't want the right answers floating around before all the answers are in. Oh, still my headphones. All right. So I want to start off this. Actually, no, I want to start off something different, because I realized that this little word here, for those of you who are on the screen, this word here, more likely, less likely. There's all these reflections on this. Is a tricky little word to understand. And what I actually want to do is literally just talk at the start about like a general concept which we all use every day and just unpack it, because it's worth understanding what the hell it means, because it can lead us astray. So let's start with the weather. 30% likelihood of rain. What does that actually mean? And this is one of these things where it's like literally like you see this every day on your weather app, but what does it actually mean? And it's worth like pausing and unpacking. Olivia.
Like 70% sunny, I guess, or like 70%.
So yeah, 70% sunny. And what exactly, but like what are these percentages? So like if I say that like the odds of flipping a coin are 50-50, there's a 50% chance that this is going to come up heads. So in that case, it's saying what? Like
it's a good chance.
It's a decent chance. It's 50-50, but more specifically, 30% of what? Like if I right now I say that, how many of us are in here? 8, 7, I do math. I say, what is 1 divided by 7? Who did 1 divided by 7? Actually, no. How many of us total? Oh, there might be. Well, there's 12 total. That might be easier. So 1 out of 12 people, which I think is like 8%. If I say 8% of people are wearing an orange shirt, what does that mean? For those of you off screen, Kyriakos is wearing an orange shirt. What does that mean exactly? Well, it means if we took all 12 of us and we were to randomly pick one of them out, like if we were to randomly take the 12 of us, spin around, and like I point at someone, the odds of me pointing to the person who's wearing the orange shirt is 8%. That's what it's saying. But what does it mean in the rain case? What exactly is being compared? Like, what am I drawing out of? Like, there's only one day here. What exactly am I asking you about?
I think it's a mixture of different factors, not so much just one.
Yeah, it's a mixture of different factors. But what am I actually asking you about? And this is the weird thing about these percentages, is what I'm asking you about is basically like an imagination game. And what it's actually doing, so whenever you see the likelihood of something, what you're actually being asked about is, out of all the possible days that could happen from here on out, what percentage of those possible imaginary days are days on which it rains, given what we know about the weather right now? So what it's asking you to do, whenever you see these 30% about the future, it's actually asking you to do this really complicated, fancy imagination study in which you're thinking, let me think about all the possible ways the world could be, given what I know now. And what percentage of those ways could it be that are ones in which it rains? And that's really, so when I'm flipping a coin, what this is saying is, if I say there's a 50% chance of the coin being heads, what I'm saying is, given everything that's happened up to this point in the universe and what I know about it, there's a 50%, half of those worlds that could happen next are ones in which the coin comes up heads, and half of them are ones in which it comes up tails. And that's really like, if you think about it, like this isn't typically how we think about these sorts of things, but what else could we be talking about in terms of percentages? What else? Because we can't like count the days in which it rains. Like if it actually rains, then it was 100%, 100% chance that it rained. If it didn't rain, there's a 0% chance. So it can't, an individual actual day either rains or it doesn't rain. You can't have a day in which it was like what would it mean for like right now it is 30% raining. No, you're either getting wet or you're not getting wet. So what is this asking about? Well, it's asking you to predict the future in some sense and saying of all the possible predictions you could make, what percentage of them are ones on which it rains? And the reason I bring this up is because this notion of likelihood and percentages and probability is something that you will read about in, people will say it like, it's really likely that you're going to have a big storm this weekend. Or, if you get this job, or if you take this class, you have a 70% chance of getting a job in computer science. If you get diagnosed with this cancer, you have an 80% survival rate. All of these are saying that of the possible universes that you are now, like future worlds that we haven't gotten to yet, of all the ones you can imagine, that percentage of them are the ones in which this is going to be the case. So when a doctor says you have an 80% chance of surviving this cancer, what that means is given what we know about you now, and given what percentage of cancer you have, in the future, like imagine the worlds, 80% of the worlds are ones in which you live, 20% are ones in which you do not live. That's what it's saying. And it's really kind of tough to wrap your head around because it really is this like weird, like make-believe game. Like probability is this strange make-believe thing where it's like, let me imagine possible universes and which one is the most likely. So it's this very bizarre thing, but it's worth highlighting just because people talk about it so much. And I think people say probability without ever unpacking because it's really like a weird philosophical concept when you think about it.
How do the people that come up with this, how do they come up with it?
So the way that they come up with it typically, and this is why the weather is so often wrong, is what they generally do is it's an inductive reasoning process. So what they do is they look at today's facts. So what they'll do is say, today's facts are say, I don't know what any of these numbers mean. I know nothing about weather. We'll say 8% on, I don't even know what the thing on a barometer is. 80 degrees Fahrenheit, clouds to south, east, wind at 7 miles per hour from the north. I don't know. All this is made up. But what they'll then do is they then look at past data. And what they'll do is they'll look and see of the times that this has happened before, there's been other days in which all of these things were true. And what we will then do is see what percentage of those past days were ones on which it rained. And the idea being that the way things have been in the past is going to be similar to how they're going to be in the future. So the idea would be we went back and there were 10 of these days that met all these criteria. And on those 10, there were 3 on which it rained. So therefore we come to the guess 30% chance of rain. And now why is the weather actually wrong all the time? And why is it that the weathermen suck at predicting? Well, it's because there's so many variables and you can never know like how all they can go on is the past. And when you have things like climate change and changes in pressure, and then like with the weather, things like how much pollution is in the air that day, or whether there's been a fire, like a forest fire in California, can directly affect these things. So it's very hard to predict. But that's what they're trying to say. They're saying of the possible worlds, it's 30%. And the reason they're wrong so much is because in a lot of ways, they're just pulling the numbers out of their butts because it's really hard to predict things like the weather. And why it's a lot easier to do like mathematics. Also why economists never predict that the economy is going to crash, because again, like it's really hard to predict all the factors and all their models ignore so many things. So never, basically economics is another thing. Whenever anyone says like, this is what's going to happen next on the market, no one knows, and they're doing their best to guess, but really it's a lot of messy guesses. But what they're trying to say is that we are making the assertion that in 30% of the future worlds, the Dow Jones Industrial is going to go up 10%. But really, and this is also why these predictions are so often like feel totally wrong, is because, you know, even if it's a 99% chance of rain, there's still a 1% chance it doesn't rain. And if that 1% happens, then you start questioning this thing. And you're like, well, that was stupid. They said 99% chance. But I mean, saying 99% chance and it's still not raining is still like possible. But yeah, statistics is actually really interesting when you break it down and like take the time to think like, oh, these are like weird make-believe numbers that people are coming up with, and they're asking me to imagine a future that will never actually exist and compare it mathematically. And then it's like kind of interesting. So that's really, and that's what political forecasting is too. They take past data and use it to say there's a 60% chance that Obama will win the election. There's a 40% chance Trump will win. And what they're saying is of 40 out of every 100 possible universes in which all the people vote, 40% Trump wins, something like that. All right. So with that in mind, I now want to talk about why on earth we are so bad at predicting it. And I think part of the reason that we're so bad at predicting it is because it's such a weird concept of what probability and likelihood actually is. So here's our first question. And again, it's going to be the same as last time, where I give you a question. We ask what's our gut feeling, and then we analyze why is our gut feeling probably wrong. So here's our first one. I'm not sure how bad the reflection is on the screen. So if you can't see this, oh, I think I have to tilt it up a little more. All right. George loves audiobooks. He nearly always listens to something like Shakespeare on his way to work and something like Jane Austen on his way home. Given that, what's more likely? That George is an Ivy League literature professor, or that George is a garbage man? So, what feels more likely? What?
And obviously you want to say A, but I feel like A is definitely wrong.
Yeah, and this is another one where like, because you know how the game is played, A is definitely going to be wrong. But the question then is why? Why is it that A is wrong? Well, let's unpack here.
I was going to say, just be generally, it's just more likely. It doesn't matter if you agree with books or not.
Yeah, so this is the key, and this is the idea, is remember what probability is asking us about, or what this likelihood thing is asking us about. And what it's really asking us about is, here's a person. All we know about this person is that they listen to a bunch of audiobooks. And we're now asking the question, what is more likely? That we live in a world in which this person picks up garbage, or that we live in a world in which this person is teaching and that's their marker? So this is what we're asking, is what percentage of the world that all we know about this person is that they listen to a lot of audiobooks. What percentage of them are ones in which they're garbage collectors, and what percentage is ones in which this particular person is a professor? And the key to realizing why B has to be true is how many Ivy League literature professors are there in the world? I mean, how many? There's like 10 Ivy League schools, and how big is like a literature department? Let's say 20, so the math's easy. So we're talking 200 people total in the world who fall into the category of Ivy League literature professors. By contrast, how many garbage men or women or individuals are there in the world? I mean, it's really hard to find like a full world number, but I looked up, there's 7 million about in just the US. And the US we have 350 million-ish, and there's 7 billion people worldwide. So if we scale that up, let's just, keeping the numbers simple, let's just say 40 million. So if you run into someone on the subway and you see that they're listening to Shakespeare, and that's all you know about them, the odds are that this person is far more likely to be a garbage man than an Ivy League literature professor, simply because of the fact that there's 40 million garbage people worldwide and only 200 Ivy League literature professors. So when you're asking yourself, what's more likely, like in the future, if you were to then find, like, another way of asking this question is, if you were to ask this person what their profession is, having just met them, what's more likely that they say, I'm an Ivy League literature professor, or I'm a garbage man? So another way of saying that is, if you were to go to the however many millions of worlds in which you possible worlds in which you meet somebody who's been listening to Shakespeare on the train, and you ask that person, are you an Ivy League English professor or a garbage man? There will be far more in which they say I'm a garbage man than I'm a literature professor. Does that make sense about just like what this idea is? So when someone says something like, this is more likely or this is less likely, one of the keys you have to calculate is, if it's the likelihood of something happening, you have to take into account like what the general population is that you're sampling it from or that you're looking at. So if you know only a single fact about someone, you then have to ask yourself, what is the likelihood that, or how many of the possible people is this member, could this member be a group? Could this person be a member of? Like, how big is the group that I'm now asking about? Now, why is it that we have such a hard time? Why is it that we have such a difficult time identifying that George is more likely to be a garbage man than a Ivy League English professor? And this is where our heuristics come back in. What did I say heuristics were last time? Anyone remember? I don't need the exact wording, but
Shortcut.
yeah, it's like a mental shortcut. It's a way of thinking that gets things right a lot of the time, but gets it wrong sometimes. And when things go wrong, they can go very wrong. So this is what is called, and so Olivia, your reasoning was exactly what my reasoning is the first time I did this. Why was it that your gut feeling says, A, George was an Ivy League literature professor is more likely?
He listens to like Shakespeare.
Yeah, so you just form this connection of like, picture in your mind what your stereotype of an Ivy League professor looks like. And it's far closer to somebody listening to audiobooks all the time than imagine your stereotype of a garbage man. It's not like your stereotype, your image in your mind of what this person looks like is not somebody who's listening to Shakespeare on their way home. That's just the way that your picture is. So what you end up doing, because this notion of probability is so weird and nebulous and kind of magical, what you end up doing when asked about likelihood is you substitute likelihood with this notion of, why am I blanking on why can't I remember the name of this? The representativeness heuristic, which is the basic idea of, instead of asking yourself this complicated question about statistics and possible imaginary things happening in the future, what you instead do is substitute a simpler question, which is, how likely or how close does this description of someone fit to my representation or my stereotype of what a person who did this would be like? And so instead of actually asking yourself this complicated statistical question, you ask yourself this far more simple question, which is, here's an Ivy League professor. I don't know, or here's a person that's listening to books. Do they look more like my Ivy League professor image, or do they look more like my garbage man image? And so what I do is I look and see, well, they look a lot more like my Ivy League professor image, so therefore this one is more likely than this one. When really that's not the question you're being asked. What you're being asked is rather this weird question about, given what I know about this person, what are the how many worlds are there in which this person is an X versus a Y? So does that make sense to everyone about how this is happening? Let me think, what was the next? I'm trying to think which of these things to bring up next on this. So, another way of putting this is to take things back to our earlier in the semester thing, is basically another thing you can think of what we're doing is we are doing an example of affirming the consequent as opposed to a good example of modus ponens. Now, let me explain this. Premise one. George listens. Oh no. If someone is Ivy League literature professor, then it's rather likely that they listen to lots of audiobooks. And if you did know that George is an Ivy League literature professor, what could you conclude from that? This is just, if we know that if someone's an Ivy League literature professor, then it's rather likely that they listen to lots of audiobooks. And we know that George is an Ivy League literature professor. What conclusion could we draw and be justified in drawing? It would be a sound conclusion, assuming the premises were true.
He probably listens.
Yeah, we could conclude that George listens. This is a perfectly good way of reasoning with modus ponens. But what happens in these cases where we have these statistical problems is we end up reversing these orders. And instead, what we do is we find out George listens, and then incorrectly, we draw the conclusion, therefore, George, Ivy League literature professor. As you can tell, I've gotten lazy about writing, but whatever. So do you see, though, as we said earlier on, if I know something is a fish and all fish swim, I conclude that that something swims. But if I know that all fish swim, or I guess if something's a fish, then it swims, and I know that something swims, that's not a guarantee that it's a fish. It could always be a whale or your friend on the swim team, or I don't know, a swamp or a sewer alligator or anything else that swims. So in the same way, even if the fact that someone's an Ivy League literature professor makes it likely that they're going to listen to audiobooks, the fact that someone listens to audiobooks does not run the other direction and make it likely that they're the literature professor. So another way to think of what the representativeness heuristic does is it encourages us to do this bad affirming the consequent and draw these conclusions about what someone's like based on how much they fit our stereotype of some group. So in this case, it's something rather innocuous. You know, you've misidentified a garbage person as a literature professor. Like, okay, it's not the end of the world. Why does this matter, though? What is the real issue with the representative heuristic in the modern world in our everyday lives? So let's think of an actual case in which this sort of thing might be more valuable or important or have more significance. Can anyone think of one where this tendency to judge because somebody of a certain group, our image of them is a certain way, we incorrectly guess that somebody who's that way must be like a member of that group?
Racism.
Yeah, so racism. So let me, and this is going to be a touchy subject, so I want to like trigger warning at the start. I want to talk about how one of the things that I think contributes to the tendency of nonviolent people of color to be treated as if they were violent comes down, and you know, police brutality against them in ways that are not statistically reasonable. Basically, why is police brutality so common against people of color? And the answer is, I think part of it is this heuristic. And so here's, I think, the thought process that goes on in the head of somebody in this moment. So it's a highly charged situation. You see someone reach into their pocket, and what is your question at this point if you are a police officer? Like, you are in a moment of you see somebody reaching into their pocket. What is the question that is flashing through your head?
Do they have a-
What is in their pocket? And here's, I think, what ends up happening, because the fact of the matter is that due to lots of very problematic, unpleasant, historical, socioeconomic facts, the vast majority of people who are members of certain, like members of gangs, happen to be from inner cities and happen to look a certain way. So if you're in a gang, if we set that you're in gang or slash, so if you're in a gang, then you tend to look a certain way. Be it race, be it something like that, just because of all these facts. To be clear, this is not to say that if you look that way, you're likely to be a member of a gang. That is 100% not true. It's just as a matter of fact, because of all these historical problems, if you are a member of a gang, you typically look a certain way. Like there are certain sorts of clothes that are more likely to be worn. And again, it's likelihood, it's not a guarantee. You can have a member of a gang who is very well dressed and in like a suit standing on a street corner and like a top hat. That is 100% possible. But there is a fact that because of the nature of our history as a problematic nation, the people of color have then ended up in these areas, and therefore gangs very often have associations with this sort of thing. Now, therefore, if you're in a gang, you tend to look a certain way. Therefore, premise 2 would be so-and-so is in gang, is in gang. So therefore, given that, you would in some sense be justified in coming to the conclusion that so-and-so looks a certain way. And while this is a very unpleasant fact about the way the world works and given all the history, that people who are members of gangs because of historical pressures happen to look a certain way, this is still going to be a perfectly reasonable thing to conclude because it's a valid argument, and this one is true because of historical factors. And if so-and-so is in a gang and it's true, then you could conclude that it's likely that somebody looks a certain way. The problem is that because of the representativeness,
I was gonna say, do people usually like switch?
exactly, because of the representativeness heuristic, and in a moment of high stress, people end up doing the opposite, which is they conclude so-and-so looks a certain way. So therefore, conclusion, they must be in a gang. And therefore, the thing this person is pulling out of their pocket is not something innocuous, it's a gun. And so in a moment of high stress, this is the sort of thing that can happen because of this bias. Now, just to back up that this is like something that I think is an explanation for this, how many of you have heard of the implicit racism tests or implicit bias tests? Have you heard of this? It's these studies, I think they were first carried out at Harvard. They've been replicated many times, but here was the basic study. You put a bunch of people in a room, you give them a computer, and you tell them, I'm going to show you a picture in a split second. This person is either going to be holding a gun or a cell phone. And I want you as quickly as possible, you're only going to see it for like, it's going to flash on the screen and then go away. I want you to press, if this person's holding a cell phone, press left arrow. If this person's holding a gun, press right arrow. That's the entire task. All you got to do, they show you one, you tell me gun, phone, gun, phone, gun, phone, gun, phone. Now, this is where the experiment, so the task itself is pretty straightforward. The experiment part comes in because, so here's what the image looks like. So just looking at this. Now, if you have like a large, that's a gun. Doesn't really look like one, but there, that's a gun. And then over here, you've got someone, and it just comes one at a time, and you just have to say phone, gun. The experiment part is they vary, and it's usually drawn pictures. They vary the race of the person depicted in the photo. So can anyone guess what the unfortunate finding, and I mean morally unfortunate, but statistically true finding was about these? So the 4 possibilities that you could get is white person with gun, white person with phone, black person with gun, black person with phone. Can anyone guess what the unfortunate finding was amongst?
I mean, black people got more hits.
Yeah, basically, here's the way that it went. The people in the study were more likely to misidentify a phone as a gun when the person holding it was black, and more likely to misidentify a gun as a phone when the person holding it was white. And this study it was originally done on like undergraduate level people, but it's been redone with people of all ages. They've done it with like young kids where instead of gun and phone, you'll show them a photo of 2 children holding a dollar bill equally and change the race and then ask them, is this child stealing or is this child giving a gift away? And even children as young as like 7 are going to be like biased and are more likely to say the black child is stealing and the white child is giving, and like all the way down to this. And so like, to be clear, just about everyone who takes this test is guilty of it. Like and it's not the sort of thing where like you're consciously thinking this out loud. Like many people who are not, and they've done this. People of color are like Black people are more likely to misidentify Black people as holding gun. White people, Latinx people, everybody falls prey to this because of these types of like representativeness bias, this heuristic that we follow. And so one of the things to keep in mind with this is like, if like, for some people, it's like, no shit, this is the way the world is. Other people, it's much more troubling. And it's the sort of thing where if it troubles you, the tough thing is to know that you are kind of working against your own implicit, like biologically infused mechanisms. Like these sorts of things are not happening at a conscious level. You have to actively go, I just had this feeling that was wrong because of X, Y, and Z, therefore I need to do it differently. Does anyone know if this is the case? So we now see we've got this heuristic, which is causing us to be racists and causing us to treat people who are in no way violent as if they were violent because we have these stereotypes and we can't help. Why is it the case that we fall prey to this? Why is it that we have this heuristic or this bias in the first place then? Any thoughts? This goes back to something we talked about last time.
Is it the stress that the
So part of it is the danger.
learned behaviors?
Yeah, so it's tied in with learned behaviors, and it's tied in, it's in some ways though, it's almost that we are pre-programmed to learn to associate, to draw grand conclusions off of simple amounts of things because of what I talked about last time with like living in the caves and the tiger coming to eat you. Where if you learn, like if you see a tiger, the first time you see a tiger do something dangerous, you are now going to draw a conclusion about all tigers because like you don't, like it could just be that like, there are probably many friendly tigers out there that aren't going to bite you the moment they see you. But the chances are that if you've seen one that does it, your odds of survival go down significantly if you start treating all tigers like that was the exception, that was friendly. So because of that, in like the caveman world where our main goal was just to survive to the next day so we could have children and reproduce biologically speaking, there was a benefit to drawing these grand conclusions about off the basis of small data. So back in the day when we lived in caves, there was no problem about drawing grand conclusions about all bears on the basis of one bear. Also, the only people you interacted with were like your close family or your family group. So there was no real harm in drawing grand claims about other groups because you'd only come across them every once in a while and there was no real harm in it. The problem is that tendency, we don't live in that world anymore, but we're biologically programmed to treat the world in that way. We're programmed in some sense to draw these grand conclusions off of how things, like we're programmed to judge books by their cover because back in caveman times, it was beneficial to do so. And the problem is that we no longer live in that world. And the fact is that we continue to have those same reptile brain things because we keep having children who just inherit our reptile brains. So in some sense, part of the reason why something like systematic oppression is so hard is because the impulses to do it, like the reason that hearing about certain things on the news can be so impressionable to children is because they're programmed to draw these grand conclusions off of limited data. And then what we end up doing is it takes a lot of effort and a lot of time to like stop yourself from doing that. And in a moment of stress, it becomes damn near impossible. And so there's this way in which just like the only way to stop yourself from doing those sorts of problematic things is to be aware of them and actively fight against them. And so I think that that's like one way in which like police brutality, systematic oppression, those are all like real world actual things where like, I mean, there's a lot more that goes into it in terms of history, but I think one of the many factors is this representativeness heuristic and this bias towards judging people by how they look. Just sometimes I just think we've evolved, like our society, we need to go back to caves. Just let's get rid of, like, we randomly pick numbers. Most people have to go with Jeff Bezos to space, and then we let the cave people stay behind. Did anyone see that hilarious petition about Jeff Bezos in space, where there was some petition that got like 500,000 signatures of people that were trying to get, it was unclear who they were petitioning, but the petition was not to let Jeff back into the Earth's orbit once he went up into space. I'm not sure how they were going to keep him out, but the petition was if Jeff goes to space, he has to stay there. I love the internet. The internet is such a strange and weird place. All right. This is another representative heuristic one. But it's another way in which the exact same heuristic can lead to a problem. So Sally's a strong believer in social justice and believes that systematic racism is responsible for much of today's inequality. What's more likely, that she's a teacher or that she's a teacher who is active in the BLM movement? Again, what is our heuristic, our gut feeling suggests is the more right answer? Yeah, B somehow seems more right. But what's actually statistically more likely? A and why. What is the reason behind this? Why is A more likely in this case?
So many more teachers.
Exactly. If you look at it like this, the number of teachers is this big, and the number of teachers who are members of the BLM movement is going to be a subset or a smaller number of that larger grouping. So all you need to have there be more teachers than teachers in the BLM movement is just to have there be one person who believes in these things, is a teacher, and isn't an active member of the BLM movement. So again, this is another representative, this one, but it's one in which basically anytime you add more descriptions to a group, the smaller the number will be. And therefore, the less likely it is that any one individual is a member of that group. But we can be, encouraged to think otherwise based on this representativeness heuristic. I have nothing more I want to say on the representativeness heuristic. Is there anything else anyone wants to add? Are we doing all right? People, computer people, you're all good?
All good. I am anyway.
Okay, any others? All right, then we're going to talk about the other heuristic I want to discuss today. Right, this isn't so much a heuristic as just a mistake. Yeah, I guess it is. It doesn't have a catchy name, but it's another way in which our thinking goes wrong. All right, in the majority of heterosexual relationships in which the wife is exceptionally intelligent, her husband tends to be significantly less intelligent than she is. Why? Anyone have any thoughts for why this would be the case? Again, what sorts of explanations do we start trying to go with? Wait, Olivia.
Opposite attract.
Yeah, opposite. We start going with opposites attract as one.
Like, I don't know if this makes sense, but maybe this is like not good, but maybe because there's not, like, her husband tends to be significantly less intelligent than she is, maybe because she's like, I don't know how to actually, I don't know.
Yeah, I mean, but we try to give these reasoned, no, you're just spot on. These sorts of reason-based explanations. This is similar to sort of the answer we gave about why does the highest percentage of colon cancer happen in the very rural republic? We start to look for explanations for it. When really, I'm going to give you another one, and it's going to be the exact same explanation. And by giving you this one, it might be easier to figure out why it's the same in both cases. Whenever I've given a student praise for an exceptionally good test score, they tend to do worse on the next test. But when I criticize someone for a very bad test score, they tend to do better the next test. Now, intuitively, what would be the explanation for number two?
that they become lazy when.
Yeah, so this is where our thought process goes. We think like the person who did well got lazy or complacent, and the person who did really poorly now is stepping their act up. So punishment works, reward doesn't. This is what the conclusion seems to be. In truth, though, that's not the explanation for this. It's the same explanation as this one. With both of them up here, anyone have, what's the key word that is the same in both? Exceptionally. Exceptionally is the key word that's the same. And what this has to do with is the notion of, sorry. This is what's called regression to the mean. Regression, and this isn't a heuristic. This is rather the way the world is. Things tend to regress to the mean, and we don't recognize it because of our questionable cause bias or questionable cause fallacy. So have people heard the phrase regression to the mean before? Has anyone heard this? So go back to your math class. What is the mean?
What did you write?
Questionable cause is under here. So go back. You remember mean, median, mode? Does this sound familiar to everyone back?
Yeah, average.
The average, yeah. So mean is average. Regression just means to go back to. So what this means is things tend to go back to the average. They go back to their normal setting. And the reason for this is because of this very nice little equation. Success, I guess you could play success / failure equals skill plus luck. So think about a time in which you did really well on a test. Part of what went into it, presumably, was that you studied and you worked hard. But that wasn't all that went into you doing very well on the test. What other things either happened or didn't happen?
Those questions were everything we studied.
Yeah, so part of it might just be what the questions were. You studied certain things that then they happened to be on the test, and the things you didn't, so there was luck involved. Also, Ned, I'm going to point to you. What do you have in your life that might actually lead to you having a tough time getting the attention to your studies that you might want? Work, one, what else? Kids. Work and kids. If your kid gets sick the night before your test is, you're not going to do very well on it. You slept an hour. Your neighbor decides to have a party and is just stomping around, you might not do well on your test. So no, if you get an A on a test, like it's very hard to get an A if you don't study at all. However, you also need a little bit of luck to go your way. So one thing because of this, when you see exceptional outcomes, usually the chances that there was good luck associated with that is very high. So even like you need to be skilled to get into the position to succeed, but you also need luck on your side. And so whenever you see a big success or you see an exceptional individual, what you can assume is there was some luck involved in it. And so in this case, whenever I've given a student praise for an exceptionally good test score, they tend to do worse on the next test. Well, here's the fact. Even if I hadn't given them any praise, they probably would have gotten worse on the next test because part of the reason they did so well was probably luck-based. Like no matter who you are, even the greatest like athletes, even the greatest athletes of all time, to win a world record in the Olympics or get the world record, things also need to go right for you. You need to make sure the wind is going your way on that day. You need to make sure that you didn't accidentally eat something that was slightly off. You have to make sure that you didn't sit next to someone on the plane who had COVID. All of these things have to go in. You have to have that skill base, but to do exceptionally well, you need some luck. And odds are the sad thing about luck is we've all had lucky days. Everything breaks our way. We've also all had very unlucky days, in which nothing goes our way. But the fact is, the majority of our days have a little bit of both. The majority of days, you might catch the bus, but like you run in, but then you realize you forgot your umbrella and you get rained on a little bit. You might have something delicious for lunch, which you weren't, or you might run into your friend on the street and get a fun lunch and then go home for dinner and your kid is sick and now you've had some good, some bad day. So whenever you see an exceptional success, you have to assume that the luck that day was exceptional, and odds are the luck the next time will not be as good. So the reason why the person did better on the next test when I criticized them, if I hadn't said anything at all, they still probably would have done better on the next test, because odds are their kid wasn't screaming, they didn't get food poisoning, the questions on this test were actually things they studied. So this idea of regression to the mean is very important to recognize, just because it can explain a lot of things that we would otherwise try to explain in other ways. So, and in this one, it's the same thing. So why is it that an exceptionally intelligent wife is probably smarter than her husband? Well, statistically speaking, if you are in the top 10% of people, if you want to say you're at the 10% of intelligence, if you want to, and say you've got 1,000 people that are on your dating app, and you're in the top 10% of intelligence, what percentage of these, or how many of these 1,000 people that you could be dating are going to be smarter than you are? 100. And how many of them are going to be less intelligent than you? 900. So simply put, odds are that even if you want to date somebody who's intelligent, if you're this smart, it's going to be hard to find somebody who's this intelligent. And if you're in like the top 1%, then 990 people of every 100 are going to be dumber than you are. And so it's just going to be statistically very hard to find someone smarter. So even though, so we might think of something like, if a woman is this like intelligent, she doesn't want to feel competition to her husband, or like we come up with these little stories as to why this would be the case. When in truth, it's just a matter of statistics, where if you're an exceptional individual, if you're 7 feet tall, you're going to be, it's going to be very likely you're the tallest one in the room. Like, that's just the way it is. There's going to be some time you're not, but it's going to be very rare. So if you're just an exceptional individual, or you do exceptionally well, it's far more likely that the next time is going to be less exceptional. You may have won the genetic lottery on height, but you're not going to necessarily win it for other sorts of things. All right. So why do we care about this one? Why is regression to the mean worth noting? Well, here's the thing. People generally, regression to the mean is not a sexy answer or explanation for things. Like you say, like, you try to get, if you're trying to write a news story and you're like, crime is going down, you don't want to say, and it's going down just because some luck and like, you know, it just happened to be high last year and now it's less. You instead want to say something like, and I'm the politician who brought down the crime rate. So what people end up doing in these cases is people end up taking credit for things when really it's just regression to the mean. And so whenever you see that something has changed, you have to ask yourself, did this change in a way that's just like complete, like this, the luck has changed. So, you know, if you go gambling and you win your first round of blackjack, don't come to the conclusion that you're really good at blackjack and that you should put your entire mortgage on it. Like, odds are your luck's going to fall. If you go to Atlantic City for the first time and walk away with $1,000, stop there, because odds are you got real lucky, because that's how like the gambling is designed to lose you money and win the house money. That's how they stay in business and get so wealthy. So yeah, also things like if you hear a politician talk about crime rate going down and claiming responsibility, ask yourself, is it really that this person did that? Or is it just that, you know, things change from year to year? I mean, there's certain sorts of things where like summers that are exceptionally hot and people are outside more, that's a major cause for crimes going up. So like the hotter the year, generally there's more violent crimes because there's more people out and about. So if a politician comes along and says, and then the next year it's a little chillier, then a politician says, I'm the new mayor. Like, you know, if crime goes down for weather-based reasons, de Blasio is still going to claim he did it. And that's just the way that these sorts of things work. If also with friends, a friend claims that they're the one who did something, ask yourself, well, maybe you're not quite as skilled as you thought you were. Another thing is ask yourself, like, don't get overconfident in things, but also if you do bad on something, don't beat yourself up too much, because if it goes really horribly, there's probably some luck involved. Another thing with this is there's all this. Oh, for those of you on computers can't see, I'm pointing at this one about criticism and praise. All the studies that have been done suggest that rewarding someone for doing a good job is much more successful than punishing someone for a bad job. However, we have this idea, and especially in certain sorts of environments like the military, where people confused regression to the mean for punishment works really well and reward doesn't work as well. So just if you want to, like, if you want your, like, sometimes punishment is necessary, but generally speaking, if your dog keeps peeing on the floor and you want it to stop, it's better to reward it when it doesn't pee than kick it when it does. So, and again, if you see something and think, I caused this to happen, ask yourself, like, is this actually the cause, or is it a regression to the mean? And regression to the mean is everywhere. Just like, it can be applied to just about anything, but it's just something that's useful to know. And it's a way of, if you're aware of the fact that the world regresses to the mean, then it's a way of offsetting our tendency to see causes in places that they aren't. The questionable cause fallacy sticks up again. All right, those were the only 3 things I wanted to discuss today. Does anyone have any more questions, comments, concerns?
Is that the name of the?
I mean, here's the thing is, if I were to give it a label, I would call the heuristic questionable cause, or I would call the heuristic correlation or causation, not just correlation, or something along those lines. And then regression to the mean is the actual explanation for it. So here's the thing, and again, you don't have to, these labels are more for your own, like, this will never come up on a test or anything for this class. It's just like a useful term to know. And if you see someone discuss, like, you'll occasionally see it. I mean, if you're a sports fan, you'll often see it in like sports writing. If somebody's talking about weather, regression to the mean is also one of the reasons that it can be difficult to get people to recognize long-term patterns in things. So like the fact that we had an exceptionally hot summer doesn't necessarily, like, people can look at that and say, well, that's not proof of any sort of climate change. Because as a matter of fact, given luck and regression to the mean, the fact is that we could have had a very hot summer even before any sort of climate change. So it can be very difficult to convince someone that there's this longer term pattern going on, because people can also then, like, the way our minds work is we have this lovely habit of pointing to whatever is going to be most useful for our own well-being at that moment. So we'll convince ourselves, well, that's just a regression. That's just an outlier. That's just random, when we want it, when that's what we want to see. And then we'll see a cause when that's what we want to see. Yeah, humans are fascinating. Yeah.
I've noticed a lot of these terms are similar, like in this case, like regression to the mean and like questionable cause.
Yeah.
They're very similar, right? I don't know if it's just,
Yes.
but I noticed like previous like examples you've given in classes. Like, I know you're very specific when it comes to homeworks and stuff, but like, let's say we confuse one or the other.
I mean, honestly, there's short answer. The fallacies I did want, just because those are things that people use in a context where it's helpful. But in terms of these things, no, because the other thing is, the reason that these terms are all so familiar is they're generally all come from the same people. And I mean, there's also this additional, like, the reason they're so similar is like completely sociological, would be my guess, of like, they very often, these heuristics were named by like a handful of psychologists who did work on the area, and then add to that the fact that psychology was like white dudes for the first 100 years, all of whom had like, they're coming from a Western intellectual tradition where certain sorts of things sounded good to them. So that's why, and then we all suffer and end up with stupid terminology. So short answer is, the only way in which I care about them is insofar as if you were in your everyday life to be looking across and see regression to the mean, you'd be like, I kind of remember what that means. But in terms of like, no. And also at this point, like, other than the midterm, like, test stuff is done. It's just going to be like, the last homework that is like a full homework is going to be another one of these, like, here's a bunch of ideas, go find some stuff on the internet that fits it. And then the paper is all going to be like a specialized thing. But if like in your paper you slightly misuse the term, I might circle it, but as long as I figure out which one you were trying to get across, I would never take off for that sort of thing. Terms are stupid, language is weird, and spelling is extra dumb. No, it's super. I 100%. The worst one ever. For those of you who are online, I'm going to stop the recording. But if anyone has any more questions, I'm going to stick around for a couple minutes. There's